Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to my supervisor in Mr. Cik Wan Muhammad Faizal bin Cik Wan Muhammad Zalani, my panel 1 Mr. Muhammad Yunus bin Ali, and my panel 2 Mr. Shahruddin bin Zakaria. Today I am going to present about my Bachelor Degree Project, which is power generation through wind energy harvesting at highway traffic area. Firstly, I'm going to start with abstract. Power generation in this project uses air force caused by vehicles moving on highways. Most wind energy is generated by the pressure difference caused by moving vehicles. This generator, vertical axis wind turbine, is a new and unique low-cost power generation method. The wind energy used in this method is used for street lights. The main objective of my project is to produce low-cost electricity without affecting the environment. Next, we continue on introduction. This field aims to harvest renewable energy to provide electricity or multiple energy sources with grid connections in the region. In countries where wind power is less feasible, an energy harvesting device such as highway wind turbines can still be used and placed on the sides of the highway. For the problem statement, in recent years, emphasis on producing electricity from renewable energy resources has increased in Malaysia. The wind has proven to be a cheaper alternative energy option among these resources. High-pressure column of wind produced by highway or expressway heavy-duty vehicles. Researchers had been trying to build a vertical axis wind turbine that operates on the concept of this highway wind energy. Next, we proceed on the objective. This project is conducted to achieve some objectives. The first one is to use the full amount of wind energy from the highway running vehicles by modeling a vertical axis wind turbine. The second objective is to design a vertical axis wind turbine that able to absorb turbulent winds typical of urban settings effectively. And the third one is to build the wind turbine using readily accessible low raw materials, along considering both the system's cost and protection. For the scope of study, this project consists of three major parts: extracting wind energy from vehicle-induced turbulence, generating adequate electricity to cover highway lighting consumptions, and the third one is reducing lighting electricity consumption. For the literature review section, here I included a table containing 4 examples from the reference list that I used in my report writing. Okay, next, we proceed on the methodology section. This is my flowchart that I use in my projects. And the second one is my block diagram of my project. The explanation of this block diagram: electrical power is produced from wind induced from the moving vehicles on the highway. The high velocity wind induced will produce a torque that can move the blades. The electrical output stored from the battery will be applied to the DC to AC converter to obtain an alternating current output for the street lamps. Next, we move to expected result of my project. The first point is expected load. The first one, I calculate energy consumption for a single street lamp by assuming the time of usage is 9 hours in a day. So the energy consumption that I got is 657 watt hour. Then I continue to assume that this project will supply 5 street lamps. So the total energy consumption in one day will be 3.285 kilowatt hour. For the second point, I also calculate the expected power that needed to be produced by the wind turbine. Firstly, I assume that in 1 hour, the number of vehicles that pass through this vertical axis wind turbine will be 50 vehicles. Then, in one day, the total time for the vehicle to be on the road is 15 hours. So the total number of vehicles travel on the road on that day will be 50 vehicles times 15 hours is equal to 750 vehicles. If the levels on the generator use 100 volts at 2500 RPM, so the volt to RPM ratio is 0.04 volts per RPM. The voltage generated if one vehicle with an average speed limit can generate wind that can spin the generator to 200 RPM is 200 RPM times 0.04 volt per RPM equal to 18 volt DC. But the efficiency of the motor is 85% as the motor used for generator. So 18 volt DC times 0.85 is equal to 15.3 volt DC. Then the total voltage produced on that day will be 15.3 volt DC times 250 vehicles is equal to 11.48 kilovolt DC. The last point is the total power produced by a vertical axis wind turbine on that day by assuming the amperage rating is 5 ampere will be 11.48 kilovolt DC times 5 ampere is equal to 57.38 kilowatt. Lastly, I continue on the conclusion. In conclusion, this project can be proceeded well as the issue is inspired from current situation. The emphasis of previous study is important in the development of this project as to gain knowledge on the working principle. Lastly, the methodology part is the preparation for implementation and estimation of results to gain from the project. That's all from me. Thank you.